Right, I think we'll get going. So thank you everyone for joining us today and for our webinar titled Risk, Resilience and Responsibility. We'll be discussing our learning and experiences helping clients protect their heritage buildings and infrastructure in a changing climate. My name's Alice Brooke and I'm a director and structural engineer based in Buro Happold's Bath office. I lead a team of structural conservation and reuse specialists, but working both in the Southwest and throughout the UK. I also head up our internal technical community sharing knowledge on reuse. Today, I'm joined by Chiara and Anna. I'll let them introduce themselves.
Good morning. My name is Chiara Faliva. I am an associate director in the facade engineering team at Buro Happold, and I'm a conservation architect. And I lead a group of facade specialists assessing and upgrading performance of heritage buildings.
Good morning. My name's Anna Wooderson. I'm a sustainability director in London. I've spent most of my working life as an architect working on existing buildings, many of them listed.
So today we'll set the scene and discuss how we can learn from the past, deal with the present, and most importantly, adapt and protect our buildings and assets for the future challenges we face. Anna and Chiara and I will speak for about 40 minutes and we'll leave about 20 minutes at the end for questions. So to kick things off, we need to consider the challenge we're facing. In the UK, we have an ageing building stock, a quarter of which is over 100 years old. Often these older buildings are traditional solid wall construction. 2% of our buildings are listed, and that might sound like a small number, but that actually equates to about 500,000 properties that are recognised for their heritage importance. We have some of the oldest building stock in Europe, and our buildings are falling short when it comes to performance. So as an example, this diagram here shows how we compare to our neighbours when it comes to thermal performance of buildings, and it's not a particularly pretty picture. So without going into all the details of the numbers, red is bad. So you get the idea.
This slide shows the variety of those 500,000 listed buildings in England that Alice was talking about. Each one of them with its own very specific materiality, construction, setting and environment, and obviously the associated very specific risks. And we should not forget that this is not just about traditional construction and traditional buildings. We have to deal with more modern and contemporary construction, like the buildings here, with their own specific challenges. And if you were wondering, yes, these are all listed buildings. Obviously, there's plenty of research and technical advice available, which was the result of extensive research done by many great organizations, with some of them are shown here. We have technical advice on how to assess buildings, adaptation, upgrades and improvements, and how to manage the change and make our building more resilient.
So what is resilience? We like this definition by Donella Meadows, the famous systems thinker, environmentalist and author. Resilience is not about the adaptability of individual parts to survive, but about the ability of the whole system to adapt and reorganize when things go wrong. And what are we worried about in the UK? Looking at the most likely hazards on the left, so storms, drought, wildfires, overheating, flooding, coastal erosion, and thinking about the likely damage to our building stock. Damage we are already witnessing. So rainwater goods are becoming overwhelmed and then leading to water penetration, significant roof damage to roofs and facades, and then ground shrinkage causing subsidence, and all that water causing mold and pest proliferation within the buildings. Obviously, flood damage, which itself leads to building erosion and loss, and overall degradation of building materials, changes to structural loadings, and very significantly loss of thermal comfort. And as a result of loss of thermal comfort, actually often an increased energy demand as well. We like this kind of diagram produced by the UK Green Building Council. It's kind of taking the most significant hazards in the UK and identifying kind of the most vulnerable areas around the UK. And I think what's really interesting here is it just shows you how varied the picture is and how important it is to look in enormous detail at the exact requirements of the local area. But it's identifying that possibly living in Peterborough and Fairborn in Wales, not the best idea at the moment. It looks like they might be uninhabitable due to flooding by the end of the century.
So in order to upgrade our buildings, we need to learn about them. So a few lessons from the past. We all know that traditional buildings are characterized by natural ventilation, vapor permeable materials, and were generally over-designed. They are inherently resilient. They are redundant in structural capacity. They are adaptable to weather to a certain degree, and they are more easily maintainable and repairable. Ultimately, we need to take advantage of this resilience. However, our indoor condition requirements have become more stringent, and we have become less tolerant. And in the past, people adopted low energy and low carbon solutions to find thermal comfort, as shown in these nice images. And awnings probably were one of the most effective of these measures. Awning have been always used to keep the heat out. They are low-tech, flexible, adaptable, repairable solution, as it was well explained in the 2021 article by Robin Pender, which this beautiful advertisement was taken from. We also need to rethink about the design process and work with the building. We need to avoid imposing the design to existing buildings, but rather try to adapt the design to their structure through surveys, investigation, testing, analysis. And this approach will lead to fewer design assumptions, will make the program more certain. There will be more circular economy opportunities, because if we know about the availability of the material on site, we can understand better how to reuse it. It will lead to better use of the building, better conditions for the occupiers as well. So basically, we need to take advantage of the intrinsic resilience. And it's a success story where this approach was used. Came from recent conversations we were having with a developer. They were upgrading a Grade 1 listed building. They spent £500,000 in assessing and investigating the existing MEP equipment, but that led to a ultimate saving of £18 million if that equipment had to be replaced. So, early assessment and investigations are really a payoff in the long term. We have several tools available to us. Desktop research, obviously, the archival research, and physical survey and investigations, laboratory testing, in situ testing. We have several softwares that can help us and are really useful in assessing different scenarios and different conditions. So in understanding what the most successful upgrades would be. But I would say that the new kid on the block is the environmental context assessment, at least in the assessment of the building. So we really need to zoom out and understanding what the risks are to the building related to the context. One example where we use data to drive the process in reducing the risk for future degradation has been the Tate Liverpool, where we are currently working. First of all, we carried on in situ value measurements to assess the actual thermal performance of the facades. We took samples, brick and mortar, to identify the material properties such as density, porosity, water absorptions, and we input this data into hydrothermal software for hydrothermal analysis to test various insulating strategies based on the actual material properties found in the building. And this helped us to find and to propose a balanced solution which adapted to the unique conditions of the facade. And we prescribed specified solutions which were different floor by floor, level by level, and facade by facade. So in this case, we modeled the moisture behavior, and we were able to manage the moisture by ad hoc and specific solutions. But then things can also go wrong, and in particularly regarding moisture management. So this example represents when things didn't go to plan in relation to the management of moisture and combined with inadequate upgrades. This is not that specific project, so I just took some photographs, but this explains, what happened. So we all know that moisture is one of the main drivers of decay. In this case, the retained facade was left exposed to rain for several months. Then existing impervious renders and paints were present on the exterior of the facade, and new impermeable insulation and VCL and finishes were installed internally. So we trap moisture led to mold and dry rot, and which ultimately led to loss of historic fabric because all of the timber elements of the facade had to be replaced. Obviously led to project delays in the program because the walls had to be dried and all of the finishes removed and replaced, and this led to an obvious financial loss. So moisture management is critical, especially when upgrading and insulated heritage buildings. And improper handling can accelerate the deterioration rather than improve resilience.
As Chiara mentioned, rather than imposing change on a building, we need to consider choosing the best use to suit the building's inherent opportunities. And that can be particularly relevant if you have an estate of assets that offer the opportunity to choose between buildings as to where you put different uses. And these images on the screen from a study we undertook of the bonded stores buildings in Bristol. They're very deep plan storage buildings, and we looked at what impact different changes of use would have on the level of intervention required. And rather than considering how to impose a new purpose on the buildings, we sort of flipped the problem and said, okay, what uses suit the building? And then we started to look more closely at how different uses might fit in different parts of the building. So heavier uses on floors with high capacity, uses like office where you needed good daylight and ventilation, but perhaps not such heavy loading around the building's perimeter, or at the top floor where you had the benefit of potentially north light roof lights. Ultimately, what you need to do is use your buildings in a way that takes advantage of what they've got to offer, rather than shoehorning in purposes that require significant modification to the building to make them feasible. And by doing this, you minimize intervention, you maximize retention of heritage fabric, and of course, these things normally go hand in hand with cost benefit too. One other key way that we can make sure our heritage buildings are resilient is to make sure future change of use is simple to achieve. Woolwich Works, which is the project you can see here, is a great example of a conservation strategy that considered a reversible approach, ultimately creating flexible spaces that are easily repurposed in the future. In this case, the buildings are old ammunition factories, and they were redeveloped to create a cultural district. Primarily, they're large refurbished spaces. And in the case of the photo, you can see on the right there, the roof was improved to provide suitable acoustic performance, but pretty much everything else in that room are flexible installations. So you can see on the right the retractable seating there. In another of the buildings, which was subject to very short-term leases, this approach was really taken to the extreme, and the fabric had minimal treatment, with the idea that further protection, be it thermal or acoustic, could be provided in a box-in-box type construction installed by the tenants and then removed when the use needed to change.
So we were looking at the retrofit and decarbonisation of a listed square in London. And while we all know awnings are a good thing, cutting out solar gain, etc., we were able to model both their embodied carbon and operational energy impact and show the client exactly what the benefit would be. So the graph on the left models embodied carbon over time, considering maintenance and replacement cycles. So comparing in pink the awnings with a cooling system in blue, with its regular refrigerant leakages plotted annually. And yes, the awnings do much better. And top right, you can see that they reduce the cooling demand by over 50%. So looking back, we would urge you to explore why buildings were built as they were, how are they used, and to then understand better how to adapt them to current and future needs, rather than make assumptions about construction, thermal performance, movement, or even the condition of building materials. We have many varied tools available to us now to discover more about every aspect of an existing buildings. And we love the fact that historic buildings are inherently resilient, proved by their existing legacy. So if walls could talk, well, they do talk, and we are learning to listen.
Right, so on to the next part of our presentation. So now if we start to think about dealing with the present, how do we do that? And actually, you can't really deal with the present without looking to the future. On every project, you often have to consider conflicting requirements. Are we preserving historic fabric or replacing to improve design life or robustness? Should we improve thermal performance? But does that mean we're adding condensation risk? Are we looking to change the use of a building, or are we going to adapt it for a new purpose, or keep it as is? Should we be upgrading the fabric, a fabric first type approach, or concentrating on renewables and ways of heating and cooling the building in an efficient manner? I thought I'd touch on a project example that had to deal with many of these contradicting requirements. This is the Newark Works in Bath. Newark Works are the crane fabrication buildings that Stotherton Pitt built, and they established in Bath in the 1800s, but their works closed in the 1980s, and from that point onwards, the building started to deteriorate. A real demonstration, actually, of the importance of finding new purpose for heritage buildings, making them relevant to ensure they're maintained. In particular, the roof coverings and guttering had failed, leading to water ingress over a long period. So when we took the roof coverings off, the structure underneath was in very varied condition. You can see here the problems caused by water ingress, ponding, mould, rotten timber, corroded steel structures. In particular, the timber rafters had rotten in places, meaning about half of them were not suitable for reuse with the refurbished roof coverings that were going to be installed in the new rainwater goods. We had to weigh up the option of trying to keep as much heritage fabric versus replacing all the rafters to produce a new base for the refurbished roof that would have the correct falls and ensure the new roof coverings would perform correctly. The project team, with the support of the conservation officer, made the difficult decision to replace all the rafters. And while we were losing existing building fabric, we were creating a robust roof, easier to maintain and less susceptible to future higher wind loading and material degradation. By doing this, we were actually better protecting the higher value heritage fabric below, which included long-span timber and iron trusses, timber floors, bath stone walls and cast iron columns.
And so the Institute of Education by Lasden, to show a more recent more recent heritage example with less inherent resilience, In fact, a building so struggling with thermal comfort that the retrofit improved productivity throughout the Institute. We looked in depth at the balance between heritage considerations, operational energy, and embodied carbon, achieving a 54% reduction in heating use across a kind of 7-phase in situ retrofit. And I think this is a good example. If you look at the next slide, shows how we assessed different envelope possibilities, and you can see we didn't actually go for the option that was kind of the most robust in terms of operational energy because of the embodied carbon impact.
Another project where data was utilized and then applied to identify the best solution with the Royal Festival Hall. We analyzed different elements of the facade and identified those contributing the most to heat loss, overheating, and internal discomfort. And these were all issues identified by the users and occupiers. We identified these elements. We analyzed the impact on the overall energy loss, and we determined that the glazed facade, although they were just at about just less than 20% of the overall surface of the facade, contributed to more than 40% to the heat loss. So we analyzed different solutions and the different approaches and identified those that were the most affecting the most efficient in improving the performance of the facade, but also the most feasible from a heritage point of view in preserving the design intent and the materiality of the building.
So protecting the future. None of our existing buildings, heritage buildings, were designed to withstand the impact of future climate change. Even the most resilient structures will struggle with projected climate impacts at the end of this century. So how on earth do we prepare for this? Our brilliant resilience team have been doing some really interesting work looking at just that across a series of portfolios. This just gives you an example of some of the work that they've been looking at. So this is a piece of work that they did looking at London's cultural infrastructure. So looking at all the cultural venues in London and assessing them against future climate scenarios. So for example, as a typology, there were many typologies, but one of them was, say, music venue, performance venues. And they identified that 414 out of 666 are in areas with moderate to high climate risk. And I think what was really interesting is that actually the difference between all the venues. So when they looking at these various typologies, they then looked in depth at a number of actual venues. For example, this one, the Wigmore Hall, was seen to have a real problem with with heat and overheating, and a bit of a problem with surface water flooding. But that really did vary considerably, again, pointing to the importance of looking at very specific buildings in your portfolio. And the resilience team has also been looking at, for example, just this is for the City of London, looking at a particular topic, for example, the resilience of social housing residents to high temperatures. And so applying a sort of very similar methodology, but addressing quite a number of different queries and issues. But looking at some work that they did, again, for the City of London, where they were looking at a substantial number, hundreds and hundreds of buildings in London, in the middle of London. And their approach was to, first of all, look at kind of climate screening, so looking at the projected climate scenarios, and then providing resilience risk assessments. And then once they have all that information, preparing adaptation measures for the client to review. So just to give you an example of this, this is a kind of data for starters that they look at in relation to the climate screening. So this shows how generally what they're looking at is taking a really a pessimistic scenario, which is the RCP 8.5, which ultimately looks at a climate change temperature of around sort of 4.3 by the end of the century. But they're also looking at a much more optimistic scenario. So they're sort of balancing the kind of the optimistic and pessimistic outlooks. And this then shows you that once they've done that, they're able to show that, for example, on the left, hundreds of assets, that says 108 assets, 99 buildings. You know, at the moment today, the highest risk is identified as drought. But you can see that when you project that through to the 2050s, it shows a very different picture, with actually extreme heat and heat waves causing many more problems. And again, you can see really a different set of buildings, but in exactly the same location, provide a very different, not very different, but a different enough story, showing how important it is to be specific. And then the next, so then they can go into more detail and looking at each hazard and exactly, you know, go into much more kind of in much more detail about exactly what the risks are per hazard. You can see here that what's come up here is the flooding and heavy rainfall, and then next kind of extreme heat and heat wave as principal hazards. And this is just an extract, but it just shows you that then what they can do for that. What they did was to look at 5 assets, all historic buildings, and they were able to sort of look at specific measures, whether it's something as simple as a threshold train or something much more significant like further studies, or there can be some quite expensive impacts. But then a client and a portfolio asset owner has got a much better picture of what they're looking at in the future. And alongside all of that is a kind of proposed phasing of measures. You know, these scenarios aren't happening immediately. This is in the future, so we can start to look at actually what needs to happen now. And most importantly, we can start dovetailing all these measures in with maintenance programs and any capital expenditure over the coming years. So sort of the lessons from the kind of work that's being done, all of this really enables prioritization of adaptation measures. So, you know, you're able to look across a portfolio and work out where to spend money and when to spend it. And also raises the scenario, the possibility that assets may fail. This is Henry VIII's castle, Hurst Castle, that basically fell into the sea a few years ago. So, you know, it will be important to look at groups of buildings and actually work out whether it is worth preserving certain assets. This is obviously a poor example because it's obviously of massive historic importance. And really important to then incorporate resilience work into asset management, plan maintenance work, and the decarbonisation work for these heritage assets moving forward. And to really understand the capacity of the asset and FM teams to engage with this process and make this successful. And we can then also help support these teams with the kind of business case for adaptation. And so it becomes a kind of proactive process rather than reactive. Certainly we found also the really important point about accurate data sets, and also linked to actually the importance of really visiting these sites as well, meeting FM teams, etc. And so overall, I think this approach of kind of producing adaptation pathways is allows for a really good kind of level of flexibility, and it's a kind of process that clients can really get behind.
I thought we'd talk about Everton Stadium because it's actually a really great example of how a risk-assessed approach to future-proofing a site, whilst considering heritage value, was applied on a project that probably most people will have heard of. The stadium was constructed within historic walls in docks in Liverpool. So this image shows the site prior to development, and the white lines are the heritage historic dock walls. In terms of wider importance, there was a need to maintain a water route through to docks further down the coastline. The problem the site had was when you look at and sea level rise. So the top image there shows a 1 in 200 year, so quite a unlikely, but can happen, seawater level today. And the lower image shows that 1 in 200 year seawater level with 95 years of climate change and impact, so sea level rise associated with climate change. So you can see the difference. The dark blue areas on the bottom right image are effectively covering over all of the historic docks. So they become submerged in water in those instances where there's that 1 in 200 year seawater level. If you were to build up the site levels, build up the dock levels to deal with that water and to create a site level that's above those water levels, you would effectively cover over or significantly affect the heritage dock walls. So instead, the team developed a strategy that maintained the current site levels and accepted there would need to be adaptation to the flood scenario in the future. Rather than design out the risk and lose the heritage value of the site, they accepted that a management and operational strategy would be employed when the site flooded, and they found ways to mitigate the impact of that if there were a flood event. So, for example, minor level reprofiling was done, reusing heritage finishes, cobbles, etc., so that they could avoid ponding. The car park was designed to flood, but the EV charging points are raised above flood levels. The stadium itself spans over the dock structures so that the heritage dock walls aren't affected and damaged underneath. So that means the actual stadium is above the flood level. But ultimately, there was an acceptance that the site use would be hindered in an extreme flood event in the future. So to conclude, whether you're looking at a city scale or an individual building, you have to gather all that information from the past and the present, a real deep dive with expert input, and overlay this with climate data. In each scenario, you need to risk assess and understand what we can do, what makes long-term sense, and make those difficult decisions. Sometimes the results will not be pretty, and we have to accept that we will not be able to save everything. But ultimately, our work to heritage infrastructure must prioritise the support of people, make buildings work for us, and they will be cared for. We must look at every opportunity, whether through maintenance, capital works, or upgrades, to reduce future damage from climate impacts. And if we can do this, we'll promote longevity in the current building stock and reduce the need to build new. Something that's also a growing focus for us all in the industry if we're to reduce our embodied carbon footprint. To be successful, we need to innovate and bring the whole industry along the journey. From clients, designers, contractors, and their supply chains, everyone's responsible for thinking to the future and protecting our heritage. Thank you very much, everyone, for listening. It's now time for questions. One of the questions I can see here is, how do we deal with extreme weather events? So heavy rain, hailstones, gusting winds, higher summer temperatures. Anna, do you want to start with that one?
Yeah, okay. I mean, we've talked about a few aspects of that, but I think that, again, it goes back to that whole maintenance program and capital projects and looking at the assets moving forward, that actually when you're making the repairs to the roof, that we're going to have to fix those roof tiles down a lot more in a much more robust way than we did before. And so there are details all over a building that will have to be looked at. And it doesn't all have to be done at once, but I think that it's just tying in all that work to work that you're going to have to anyway. And we've talked about the kind of overheating, you know, when you provide awnings and all that sort of stuff. So it's gradually overlaying that kind of those resilience measures, I think, as you go through the next few years.
Okay, should we go on to another question? Okay, next one. To what extent is our heritage building estate at the cost of our climate? Or I guess that's saying, are we going to lose our heritage infrastructure because of climate concerns?
Yeah, this is interesting, isn't it? I think organisations like Historic England and all these kind of organisations, the English Heritage, are going to be well, they are asking. We know they're asking these questions, and that we will lose buildings. But I guess that's the whole point of the prioritisation piece, isn't it? That we look really carefully at what buildings we can keep and can repair and can maintain moving forward. And if there are buildings that are going to be underwater or falling off a cliff, then arguably we can't spend money on those assets.
Exactly. We need to always be looking at that long-term picture rather than only dealing with the short-term problems, so that we're directing efforts to the right places and making sure we do keep what, as you say, Anna, what can be kept, and we do maintain our buildings as best we can, so that we minimise those that are lost along the way.
I'm just finding out the answer to one of the questions.
Another question.
Yeah. My colleague says it's not published yet.
Oh, sorry, we need to read the question out. So there's been a question that says, can you please share the Sustainable Spaces for Culture report? Sorry, Anna, you were saying it's not published yet.
Yeah, it's not published yet, but no doubt in time, absolutely.
Okay, another question. Useful to hear the panel's views on retrofit risks around moisture management. And you spoke a bit about that, Chiara. I don't know if you want to.
Well, yes, I think the best
thoughts.
way to reduce risk related to moisture is, first of all, repair and maintain our buildings. So we need to avoid, obviously, to get moisture into our buildings. But then when we need to retrofit and thermally upgrade facades, the most important thing is to assess the actual properties of the existing materials. So laboratory testing, really, to it doesn't have to be too extensive. It doesn't have to, very costly, but just the main properties, such as density and water absorption of bricks, already gives us a good understanding of the behavior of these materials when in contact with water. And then I think we have very powerful softwares that help us in simulating and predicting different scenarios. So obviously, when we add insulation internally to facades, there's always a risk of condensation forming on the now colder internal face of the walls. So the work that we did at Tate that I was talking about earlier was really to define just the right amount of insulation based on the existing indoor condition, material properties, and outdoor condition to prevent the risk of condensation forming. So it's, I would say that how to manage is repair buildings, avoid moisture, but then knowing the materials and their properties, and simulate, and using softwares to simulate and find the balanced ad hoc solutions for the upgrades.
Yeah, it was mentioned that the environmental context assessment was being utilised as a relatively new tool. Could you please expand on what forms part of this assessment? I suppose I can start on that one. Our thinking was that we normally, when we're looking at a historic building, we go through those sort of various tools that we have available, and often it starts with desktop study and a visual survey. And really the point we're trying to make is that rather than just looking at the building, we really now need to be across all of those tools thinking about the wider context. Is the building, does it have some facades that are particularly exposed to rainfall? Are there flooding issues on the site? Are there particular areas with sort of funneling of wind? All of these things that maybe in the past we perhaps wouldn't have paid as much attention to really need to be part of that study. I don't know, Chiara and Anna, if you want to add anything to that.
Yeah, it's really to look at the whole context to identify specific risks. So it's sort of a zooming out, as I was saying, and focusing on the context as well.
And it might use lots of different tools in order to understand that information, whether it's flood mapping, or it's just gathering more data really, so that we can properly understand the future impact that climate might have on a particular building or site. Another question, have you noticed an increase in focus on climate resilient asks from clients in recent years following climate emergency declarations and the increasing climate events?
Yeah, well, I can kick off if you like. I think it's fair to say the work that we're doing within the sustainability team is ballooning, and this is both locally, like the kind of work that we've been talking about in the UK, but also globally. And it's at a multitude of different scales as well. We're looking at the resilience of cities to withstand climate impact, and we're also looking at individual buildings. And I mentioned earlier, we're also looking kind of asset portfolios in a way. So it's working on a number of different scales, and particularly interesting work that's been done by the team, for example, in the kind of C40 work, which is looking at cities elsewhere. But I think what we're also doing is we're including more analysis within our general sustainability scope, so that we actually identify problems regardless whether a client has asked for it, because we now have enough data that we can start sort of running relatively quick analysis, upfront analysis. And at least that will identify whether actually we can then say to the client, well, do you know what, I think you need to look at this in more detail. This is quite a significant issue. We were looking at a building recently very close to the South Coast, and it was, if you looked at any climate data, that building's not going to be in very good shape in 20 years. So I think that these are conversations that we increasingly have to have.
But I would add that maybe it's also more requests from clients because of real issues they already have now. So we are already trying to address real problems that are affecting their buildings. For example, in terms of capacity of their roof drainage. So buildings are already flooding, and or another issue that we have to deal quite often in the facade engineering team is overheating, especially. And I probably touch on the next question, which is quite relevant to overheating. If there are challenges of upgrading modern, postmodern heritage buildings, which may have been built with less robust methods of construction, for example, not brick or stone. Yes, they are very challenging, and because they probably have a lesser degree of that intrinsic resilience that traditionally built buildings have. And I think, maybe touching on the Royal Festival Hall, we've seen that by replacing the monolithic single glazed glass panels on the facade, we are already improving the thermal performance by 60%. And if we had to replace the whole glazed facades with the new thermally broken frames, we would improve the thermal performance by 80%. So, there are ways we need to balance, obviously, because we want to maintain the fabric, the original fabric of these buildings, but also, particularly in this typology of buildings, we need to preserve the design, the proportions, the ratio between the opaque walls and the glazed walls. So these are all very specific challenges. There are usually a lot of thermal bridges in these facades. So it's more, again, working with the building. We usually tend not to impose, for example, U-value targets, but we work with the MEP team to find a balanced solution. So we know that we can achieve certain U values, which are obviously not compliant. Most of the times are not complying with Part L. But yes, it's working holistically and trying to find the best solution for the building.
I think really worth also just differentiating between modernist design and postmodern, which actually provides very different challenges. So what Chiara's been talking about, I would say, predominantly kind of modernist detailing, which is, yes, very leaky, thermally inefficient, blah blah blah, but at least there's a simplicity to it. I think the real challenge is when you kind of come more this century or the last part of last century, you got construction methodologies that are just so complex and so difficult, so much more difficult to unpick. For example, the illustration that Chiara had of Outram's house that was the most recently listed building, which is completed, I think it was 1999. Anyway, so that would be a whole series of other challenges. So worth just logging that as well. So the next
question. What about this one? What are the common challenges being faced by your clients or market in achieving their net zero aspirations, i.e. funding, general appetite, lack of technical expertise, etc.?
So can I just kick off with that one, and then I'll say that one aspect that we're finding is that, to be completely honest with you, retrofit is a lot of retrofit measures are hard to justify financially a lot of the time. If you're applying a solely net zero lens to your retrofit measures, chucking in a heat pump, putting on some PV panels where you can, will be a much more cost-effective way of decarbonising your building. However, if we start to apply a different lens, like for example thermal comfort and longevity, resilience, all those kind of lenses, then these retrofit measures start to stack up a lot more clearly. So I think that this is kind of back to the kind of fabric first, fabric fifth debate, but that there's nuance to all of it, and that every different building will throw up different opportunities, and you'll have to sort of balance that against the sort of cost return you get. Chiara, I don't know whether you want it, or Alice, did you have anything to?
No, I think you touched
lack
on.
of technical expertise, obviously we're not going to say that at Buro Happold, but maybe within the industry, within the whole construction industry, yes, there probably is a bit of a lack of technical expertise.
Yeah, I think probably the what we're missing the most is data. So there's no much data about the existing performance of these buildings. So it's very difficult to predict and really fully understand the behavior, the energy consumption, and the thermal behavior of the buildings for lack of data.
And I think maybe that also, in a way, links to the question above about is there enough guidance in the industry relating to heritage and climate? Because I suppose the problem we have is that these buildings are so bespoke, and there's some amazing guidance with the industry, and people are doing incredible work. But it is quite hard to you can't apply blanket guidance, that's for sure.
I think it just going back a step to the question about achieving net zero aspirations, I think there has to also be an acceptance that sometimes we need to use our buildings differently now. So, for example, we do quite a lot of work in the higher education sector, and usually academics have their own offices and they're used for maybe once or twice a week, and you're heating a whole building for that. And there's various studies happening to look at how you could increase the use of spaces so that you're not building new buildings to have more space, when actually you could be better utilizing the spaces you have already, and in that in itself will help you reduce your operational carbon output. That's all the questions at the moment. Is there anything else anyone wants to add?
Just who should be providing this guidance on the second from last question?
Yeah.
I mean, there are just so many people, as Chiara's slide showed, there are so many people working in this area providing fantastic guidance. So it's a bit like the whole net zero landscape generally. There's guidance everywhere. So I think Chiara's point is kind of shifting us more to the provision of more data, which I think is an interesting one.
Okay, well, if there are no other questions for today, then I'll just say thank you very much for listening. And thank you for your time and for your input with questions today. And do get in touch with Chiara, Anna or I if you have any further questions or wish to continue the conversation.
Thank you very much.
Thank you.